Hello there, grade 12 ABM students. This is the third part of our discussion about the time value of money. Let us now talk about loan. A loan is the sum of money borrowed that is expected to be back with interest. An amortization is paying the debt with regular payments. A housing loan is an example of an amortizing loan that requires the borrower to pay. Payments can be annually, semi-annually, quarterly, or monthly. When debts are paid using the amortization method, it is important to know how much interest is paid and how much money is reduced in the principal borrowed. This can be seen in an amortization schedule or table. Let us start our discussion by answering this question. What is an annuity? An annuity is a series of payments required for a specific number of periods. An annuity due is when payments are due at the beginning of each payment period. When the payment appears at the end of each period, it is called an ordinary annuity. The present value of an annuity is computed as present value of an annuity equal to C multiplied to 1 minus 1 over 1 plus R raised to T all over R, where C is equal to cash flow stream, R is interest rate, and T is time. Instead of using the formula 1 minus 1 over 1 plus R raised to T, you can use the present value interest factor for an ordinary annuity table. Simply find the intersection of the relevant time period presented in rows of the table and the relevant interest rate presented in columns of the table. Using our example from multiple cash flows, which was discussed last week, the PVIF A given 3 years and a rate of 5% is equal to 2.7232. To get the present value of our example, we will just multiply 25,000 pesos to 2.7232, and the answer is 68,080, which is the present value of the annuity. Our example is an ordinary annuity, since the cash flow is required at the end of each year. If the cash flow happens at the start of the year, then it is annuity due. If the cash flow stream lasts forever or is indefinite, then it is a perpetuity. The present value of a perpetuity is determined by simply dividing the equal cash flow stream by the appropriate interest rate. Let us say, you expect to receive 25,000 pesos annually, wherein we have 5% interest rate. In perpetuity, then the present value is determined by present value of a perpetuity is equal to perpetuity over R, wherein our R is our rate. So we have here 25,000 pesos divided by 5%. So we have here the present value of our perpetuity is 500,000 pesos. Let's now talk about the loan amortization. A classic example of a business transaction that pays out an equal cash flow stream regularly is an amortizing loan. Most housing and car loans are amortizing loans that require the borrower to pay that equal amount either annually, semi-annually, quarterly, or most of the time monthly. We have here two cases. First, equal principal payments, and the second one, the equal regular payments. Let us look at an example of a corporate loan to illustrate how a loan amortization table is prepared. For some corporate long-term loans, principal payment is fixed and the interest expense is adjusted based on the declining principal balance. For For our illustrative example, on July 1, 2015, BB Company borrowed 3 million pesos from ASC Bank at the rate of 10% a year. The loan is paid at the rate of 500,000 pesos every December 31 and June 30 until the full amount is paid. This is the amortization table for the loan. Here are the steps in constructing the amortization table for equal principal payments. First, find the interest by multiplying the interest rate with the outstanding balance. Note that the interest rate of 10% is for 1 year. Therefore, for 6 months, the interest rate is only 5%. Here is the computation for the interest expense from June 30 to December 31, 2015. Interest is equal to 3 million pesos multiplied to 10% times 6 divided by 12. We have here 150,000 pesos. Second step, find the payment by adding the principal payment, which is 500,000 pesos, with the interest computed. We have here 500,000 plus 150,000, a total of 650,000 pesos. Next, subtract the principal payment from the principal balance, which is 3 million pesos. So for our principal balance for December 31, 2015, we have 3 million pesos minus 500,000 pesos. For the next 6 months, ending June 30, 2016, the interest expense is only 125,000 pesos because the principal balance is already reduced to 2,500,000 pesos as of December 31, 2015. For our computation, we have 2,500,000 pesos times 10% times 6 divided by 12, we have here a total of 125,000 pesos for our interest. Repeat the process up to the last period time, in this case up to June 30, 2018. Continue until the principal balance reaches 0. The amortization schedule shows that as the principal balance decreases, the total payment and interest payments also decrease, but the principal payment is constant. Some loans require equal regular payments. In this case, how is the regular payment determined? For our example, you plan to purchase a house worth 3 million pesos. Assuming you incur a 10-year loan that is repaid in equal annual installments with an interest rate of 10%. What is the annual mortgage of payment? For our formula, we will use C is equal to present value of an annuity over PVIFA. C is the regular payment. Based on our problem, the present value of our annuity is 3 million pesos. And then, we need to determine the present value interest factor for an annuity wherein we have 10% for rate and 10 years for our term. Using our table, we can have 6,144,000. Calculating the value, the regular payment is 488,236 pesos and 57 cents. Let us discuss the steps in constructing the amortization table for equal regular payments, wherein the principal and interest are combined. First, find the payment at the end of the period by using the formula C is equal to present value of an annuity divided by our PVIFA. Based on our computation, we have 488,236.57 pesos. For our second step, find the interest on the first period by multiplying the interest rate with the loan. So we have here 3 million pesos multiplied to our 10%. And then, for our third step, subtract the interest from the payment to get the principal payment. Again, subtract the interest from the payment to get the principal payment. For our fourth step, find the outstanding balance at the end of each period. How? Subtract the principal payment from the outstanding balance, which is our 3 million pesos. So we have 3 million pesos minus 188,236.57. For 2016, our principal balance is 2,811,763.43 pesos. Repeat the first 4 steps to compute for the payment at the end of the period, interest rate, principal payment, and outstanding balance for the second to the last period. Thanks for watching this video. For your questions or clarifications, you may send them in our class group chat or you may raise them during the Zoom meeting. Good luck and God bless you all.